Myself, I'm Julie Millington. I am the Director of Strategic Planning for MIS of Canada. My background, so I help new companies get launched, create the strategies, help raise funds, and so part of the objective here today is to demonstrate the technology for this exciting company, and we are looking to have investors participate. And so the real focus for today is to look at the technology, ask questions, and be able to really show you how this works. And so I am joined by Oswaldo, and I'll let you lean in here.
Thank you very much. Good morning, guys. Good afternoon, guys, and good evening, guys. I'm not sure where in the part of the world you guys are in, but we are going to now be able to display the technology and introduce you to the science behind it and how it works. For that, it will be Dr. Schultz doing the presentation, and the main questions that you have, we will be able to answer. Anything you may have a question, anything you may have a doubt, please ask. We will be able to display it and show you and give you an idea of where we can go from here.
So I'm going to introduce you to Dr. James Schwartz. Dr. Schwartz is the inventor of the electromagnetic technology that forms the foundation of magnetic impulse systems, our power generation platform. So over several decades, actually over 30 years of research, Dr. Schwartz has conducted extensive research and development into advanced electromagnetic systems, energy conversion technologies, and innovative approaches to electrical power generation. Originally from German, Dr. Schwartz's engineering and scientific work has focused on challenging conventional approaches to energy production through the application of electromagnetic principles and novel system designs. He's developed and continues to refine the core technology behind the MIS basis. He's worked collaboratively with the MIS team, providing technical guidance, deep expertise, design expertise, and ongoing support of the testing, validation, and any future systems enhancements that we're planning on doing.
Explain to you exactly the steps by steps how energy is captured, how energy is transferred, and how energy is output to a regular DC and AC mode. The key and the science behind it are these specific boards. They are in this system, and he will explain to you how that system works. So if there's any questions, we will be answering, but I would like to Dr. Schultz to explain the technology.
Okay.
Yes.
So for right now, how does this work?
Okay. All right. Well, most people understand lightning. Okay. What we're doing is the same thing that happens with lightning. Okay. The only difference is when it builds up in the clouds, it has to release itself and it strikes the ground. Now, what we're doing is we're copying that. Okay. But to keep it from having to strike the ground, we have these here small 6 wires here, speaker wires, 1 to each plate in here, so that when we get overage, it'll bleed off into the ground to the unit that's in the ground.
Okay.
That's to keep it from destroying itself.
Because the frequency changes.
We had to go through that for
Yes.
a few years now. This is already 4 years old now. It's supplying everything in my backyard and my son's workshop over there, a woodworking shop with all those heavy tools and stuff. Now there's an air conditioner I just took outside, so we have some room.
Okay.
So when the air conditioner's in here during real hot weather, it automatically turns on and it cools it down in here.
Okay. So how do these take in the electricity?
Okay. Now what we're doing is we are using frequencies. We send frequencies to these plates. There's a plate right there. Okay. That'll give you an idea. This here is the older plate here.
Okay.
This here was in a portable unit, which don't last very long. That portable one that we use for my lectures and stuff, it'll run about an hour, and after an hour, it'll start building up and burn up everything.
So this one has been running continuously for 4 years,
For 4
correct?
years, yeah.
And so these boards, how does it take in the electricity to?
Well,
Make
when the
electricity.
frequency goes to the plates,
Okay.
the plates cause the material around it. Okay, whichever you use, I'm using on these. I'm using aluminum plates instead of the bismuth plates, a new one.
Okay.
It tells them to release their electrons. The electrons go back here, through here. Here they are split up, and so that we can use them for use, they go here to this this unit here. Okay, this heavy coil here is very important because it brings it down to an AC setup that we can use. Otherwise, it's unusable. It's too powerful. Okay. And then from there, it goes to all these plugs, and that runs everything. And it goes outside here. It runs my security at nighttime. Everything is run by this. Now, 4 years ago, when we first put this in, my son and I, we all were so happy to get it working. We said, oh, good. So we ran a long extension cord out to the electrical box. And we was using it for my house. The next day, I got a knock on the door from the electric company. They came over and said, sir, our computers at our laboratory shows that you're using electricity from an unknown source.
So the big thing we really need to do here is make sure that we talk about how
this works.
Yeah. So how does it work? How does it once the electricity comes, or sorry,
Well,
the
Electrons.
This here plate here is put together. It's got 4 of these inside of each one.
Okay.
Okay. Now when the frequency are just like one of those frequencies is one of the 5 frequencies we are using.
So you've been able to, and I
So
think
we
maybe
have
you
to
can-
be very careful.
So the frequencies, what they do is they excite the electrons, or they excite these coil systems and produce electrons, and the electrons are coming into this board, and it becomes now part of almost DC power. Almost DC power. It gives you the same reading, almost the same reading as the DC power, and then comes onto the inverter systems and creates, and in from the inverter becomes a DC power, and then we can run all the power.
So if you plug something in right now, how do you can you see?
Of course, we can take. Can we get that spotlight? Can we get that?
We're just gonna try plugging something in here so we can actually see. This actually shows you, the power usage and the information. So what we'll be able to see here once we plug something in. So Oswaldo is going to plug in this light.
So this system is generating power right now to run these computers. We have 4 different computers here. They're actually Bitcoin machines that he's running to generate an income. And the power from here is going to the other buildings. Yeah. Right here. James, this is what I want to do.
Okay, so plug that in.
This one is too small.
Okay.
I gotta get a more powerful light.
So did that reflected you plugging that in, correct? Can we unplug it and plug it in while this is here so they can see? Sorry. Okay, so see the change when we unplug it? And then if you want to plug it back in for me. And then so you can see it changes again. based on the usage when you turn on the light and it runs the power. Is there anything else that you want to tell them before we open for questions?
No, I believe you have seen the beginning and to the end of the process of the system. So now we are ready for questions because that is what we need to explain to you and measure whatever you need to do.
Julie,
Yes.
Put it in, show it.
what's in the ground? You said that there's 6 wires that goes to the plates. What is in the ground?
And let me show you what is in the ground, if you don't
Okay.
mind. Let's look at the ground.
We're going to go for a walk so you can see that.
Okay, explain, James, what they are.
Okay. Now these here are very thin line. You couldn't run a lot of electricity through that; it would burn up. You know what I mean? Okay. You have to have one of these for each plate, so that when the electricity builds up to a certain point, it keeps bleeding off at a small scale to keep it from burning up the plates. So this is very important. You need it.
Perfect.
And what is in the ground? What do you have inside?
Well, these are 4 feet down in the ground.
That's what they are.
Okay. They got a special chemical compound inside of the tubing that my son at NASA, he gave us that. And it's just a conductive material is all
To
it is.
absorb the extra energy that those boards are
Yeah.
producing in.
Yeah.
Okay. And
Perfect.
that is the only wire coming in or going out of that box.
That's it. Those 6 wires there and a ground wire. There's one ground wire in there.
Okay.
Right down here.
Well,
That ground wire goes outside to a faucet.
Yes.
That's just
The ground for shock.
so you don't get shocked.
Okay.
Okay.
Where are the plates picking up the field? It's picking it up right there inside the shed, inside the container, or is there something receiving it on the outside or below?
No, the plates are just sitting in this wood box at this time, but they are not connected to anything else except to the bleeding cable.
Right.
So he's
Well-
asking where is it picking up or absorbing
The
the
energy
electricity from?
around you, the energy that is around you
Okay.
is what. So the energy the earth and the sun produces around you is what these boards are taking the frequency.
Well, all we're doing is using the frequencies to get electrons.
Correct.
Electrons flow here, over there. Okay. Okay,
Yes.
that's
So
that's
I-
500
There is nothing
watts
else
there.
connected to the system. The energy, the frequency are bouncing from these boards is what capturing the electrons and producing out. There is no a physical connection to any source besides the frequency around you.
Oswaldo, the 6 tubes that are outside, they're a mandatory part of are they capturing as well frequencies?
Each board, if there are 6 or 10 or 12, each board will have to have one, and that is for the excess energy, the extra energy that these boards are producing. If they are not consumed, they will heat up the boards and they will melt it. And that is what we are changing. All the extra energy that those boards produces must leak to the ground. Tomorrow, we are going to be using these graphite boards, which we are now developing. The same concept there in these boards with the same coil system or newer system will be done in these boards. Why we're using graphite boards? Because they absorb a lot more heat and we can maximize the output of each of the boards. Today we are producing approximately 5 to 7 kW out of this system, and we will be establishing 1 to 10 kW system to start. That is a next step for the prototype. These graphite thing boards.
So the external piece is just to bleed the energy out. It doesn't collect anything,
None.
right?
None. They are just to drop extra energy that produces leaks out. Not in a large amount, but in a small amount because we are consuming and the
Okay,
process.
now this,
Now, a question here.
Yeah.
So let's talk about scalability.
Yes.
Scalability. I'm looking to see if you had a, you know, if we could go to a meg, that would be great, right? So you need certain area of square footage to pick up the frequency in order to drive the same as in a 5 kWh? Do you need more of an area open for, you know what I'm saying?
Yes, the answer is no. We don't need additional space. We believe the 1 meter by 1 meter by 1 meter box will be able to give us 100 kW output of the energy, and multiple of those will become 1 megs. So the next phase, which will be a 10 kW system, will be a base model to start manufacturing from that point forward to 100 kW, and then we go to a 500 kW in 1 meg. Very small. 1 meg can be delivered half of the container, but delivered space-wise.
What does that do to the bleeding off of the energy? How much does that get scaled up under the same
That's correct. That's correct.
sizing? And yeah,
That's
okay.
correct.
Yeah. So we'd have
Um,
tubing that comes out of the side and goes into the ground, and there'd be one for each board.
Right now,
eh,
we are 4 feet in the ground. We believe we can go in 8 feet or 10 feet copper plus additional minerals that he has, and to absorb, accelerate the absorbing the extra energy that the system is leaking,
As Waldo,
a form
quick,
of leaking.
well, Oswaldo, you're diverting some of the heat and everything else through the ground, right? And siphoning of that extra electrons that you don't need is going through back through that way.
That's
Is
correct.
there anything? I'm just thinking, right? Um, is there anything that those electrons that you can do to create another byproduct with it? Because if you're generating heat, then you should be able to tack that on to, I'll just talk about it this way, into a building and tap it into the building and use that heat and recover that heat. Then it doesn't become it becomes an asset as well, right? Is there something that you can do with the rest of those electrons or that heat?
The amount of leakage that we think we will develop based on the size of the unit that you will purchase in the future will be minimum. So there will not be a large amount of leakage coming out. We must maintain safety, and that's why we will have those. But to use that additional energy all depends on how much loss of energy we have in those wires, and we will need to test it individually.
Yeah. And I think the objective is to continue doing more testing and more R&D as we grow this to see what other applications, what other sizes we can do. We've talked about, like right now, these have to be situated in one location. With more R&D, we may be able to make these mobile. Like there's all sorts of additional R&D as we progress through this. Right?
Correct, correct. Today we must be a fixed location. Tomorrow we may be a mobile location, so we can actually create a unit to be in an electrical car and produce power. But today we must be grounded and limited to some of the things we're doing it.
Yeah. Any other questions? No? Okay. Well, I really appreciate everyone's time today. We will be actually we've captured this on video. We have other investors that are interested in having us send them a copy of this as well. We're actually going to do some additional filming and picture taking and have additional information available. You have our contact information. So if more information or more questions come up in the future, please reach out. You can reach out to me and I will speak with Dr. Schwartz or Oswaldo directly and get you responses. So thank you so much for your participation. Very much appreciated. Do you want to say goodbye?
Thank you, guys.
Perfect.
Okay.
Say thank you and say
Thank
bye.
you, guys.
It was
You
nice
too.
meeting you.
Thank you, guys.
Thank you very much, everyone.